Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you for practicing your class 12 question papers as well as your entrance exam question papers. Also, you must download our app. The link is available in the description box. Here we go with the question number 1. Today we'll be solving CBSE class 12 Mathematics 2020 outside Delhi set 1 paper. There will be some choices in the questions available also, and around 40 questions we'll be doing in this video. So let's start with question number 1. Very best of luck. Here we go. Question number 1 to 10, they are MCQ questions. Each is carrying 1 mark. So the first question is the value of sine inverse cos 3 pi by 5 is equal to what? Okay. The options are given to you. So now this can be written as sine inverse cos. If I want to change it into sine, it will be sine pi by 2 minus 3 pi by 5. I can write like I'm using the trigonometric ratio of complementary angles over here. So this will be equal to sine inverse of sine something. Let's write this sine inverse of sine. There will be the LCM 10. 5 pi minus 6 pi. So that's equal to sine inverse sine of minus pi by 10, which is equal to minus pi by 10. That's it. You have option C as the answer. Hope you understood that. Let's move to the next question number 2. So here it says if A is the matrix, this and B is this matrix, and X is this matrix, and Y is this matrix, you have to find the value of AB plus XY. So very simple as that, right? So this is the A matrix, 2 minus 3 and 4. The B matrix is equal to 3, 2, 2. So if you're having the number of rows and number of columns, you have 1 row and 3 columns. So the order of this matrix is 1 by 3, and the order of this matrix 3 rows and 1 column. So you know the multiplication rule. If the number of columns of the first matrix should be equal to the number of rows of the second matrix. Here is 3 and here is 3 as well. That means A into B. This is possible. The multiplication of the 2 is possible. So it will be 2 into 3 and plus 2 into minus 3, 4 into 2. Okay, so that's equal to 6 minus 6 plus 8. That is 8 only. This is the matrix AB. And let's go for XY. The XY is X was equal to 1, 2, 3. Y 2, 3, 4. So order of this matrix is 1 row, 3 columns, and 3 rows, 1 column. X comma Y will be equal to 1 into 2 plus 2 into 3, 3 into 4. This gives you 2 plus 6 plus 12, that is 20. And you have to find out AB plus XY. That is 8 plus 20, which gives you 28. So this makes your option A to be the correct answer. Hope you understood that. Let's move to the next question. Question number 3. If determinant of 232 xxx 491 plus 3 is equal to 0, you have to find out the value of x. That means determinant of this matrix plus 3 is equal to 0. Then you have to find out the value of x. Okay, first of all, let's find out the determinant of this matrix. That's 2, 3, 2, x, 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 4, 9, 1. This is equal to, this will be 2 into x minus 9x minus 3x minus 4x plus 2, 9x minus 4x plus 3 is equal to 0. This makes it minus 16x and minus 9x. This is plus 9x plus 10x plus 3 is equal to 0. 3x plus 3 is equal to 0, or x will be equal to minus 1. So that means option C is the correct answer. Hope you got that. Next, question number 4. You have to find the integral of limit 0 to pi by 8 tan squared 2x dx is equal to. Fine, let's say this is equal to I, 0 to pi by 8 tan square to x dx. This integral is okay, I can write on tan square as secant square 2x minus 1, right? 0 to pi by 8. So this can be written as integral 0 to pi by 8 secant square to x minus 0 to pi by 8 1 into dx. So what is the integral of tan x secant square x? It's tangent x to x, tangent 2x upon 2 minus of x. The limits are 0 to pi by 8. This will be equal to tangent of pi by 4 upon 2 minus pi by 8 minus tangent of 0 minus 0, right? So what is tangent of pi by 4? That's equal to 1 by 2 minus pi by 8 minus 0. This makes 4 minus pi upon 8 will be the answer of the question. That is option A is the correct answer. Hope you understood that. Let's move to the next question. Question number 5, if the dot product of A and B vector is equal to half of the magnitude of A vector and the B vector, then what is the angle between both of them? Okay, see, on and on, you know the formula for this. The dot product of the two vectors is given by the magnitude product of the magnitude of the two vectors multiplied by the cos of angle between them, right? And you are given that this is equal to half of magnitude of A and B vector. So this is equal to A vector, B vector, cos of theta. They will be cancelled. So that means cos theta is equal to 1 by 2. And what is the, that means what is the value of theta over here? This 1 by 2 is for cos of 60 degree. That means theta is equal to 60 degree, which makes option C to be the correct answer. Hope you understood this. Let's move to the next question. Question number 6, the two lines x is equal to ay plus b and z is equal to cy plus d, and x is equal to a dash y plus b dash and z is equal to c dash y plus d dash are perpendicular to each other if what of these is true. So you have the two lines. From here, the two lines can be written as x minus x1 upon a1. Question number 6, two lines x is equal to ay plus b and z is equal to cy plus d, and x is equal to a dash y plus b dash and z is equal to c dash y plus d dash are perpendicular to each other if, see, if you have two lines x minus x1 upon a1 is equal to x minus y1 upon b1 is equal to z minus z1 upon c1, and the other line x minus x2 upon a2, y minus y2 upon b2, z minus z2 upon c2. They are perpendicular to each other if A1 into A2, B1 into B2, C1 into C2 is equal to 0. Now, given lines can be written as, these given lines can be written as lines can be written as x minus p upon a is equal to y minus 1 is equal to z minus d upon c. Right, this is from like the first one, and from the second one it can be written that x minus p dash upon a dash is equal to y minus 1 y upon 1 z minus d dash upon c dash. Let's say this is 2. Now as it's given that these two lines 1 and 2 are perpendicular, if they are perpendicular, that means a into a dash plus 1 c into c dash is equal to 0, which makes a dash, c dash is equal to minus 1. And this makes option D to be the correct answer. Hope you understood that. Let's move to the next question, number 7. It says two planes x minus 2y plus 4z is equal to 10 and 18x plus 17y plus kz is equal to 50 are perpendicular if k is equal to what? So you are given the two planes x minus 2y, 4 Z is equal to 10 and 18x 17y and kz is equal to 50. These are the two planes. So if these two planes, let's say this is P2, you are given that they are perpendicular to each other. If they are perpendicular to each other, that means 18 into 1, that is 18, minus 2 into 17, 4 into k is equal to 0, which makes 18 minus 34 plus 4k is equal to 0, or 4k is equal to 16. That makes k is equal to 4, and option B is the correct answer. Hope you understood that. Let's move to the next question then. Question number 8. In an LPP, if the objective function z is equal to ax plus by has the maximum value on two corner points of the feasible region, then the number of points at which z max occurs is... See, this question is a question of LPP, that is a linear programming problem. Linear programming is a method to achieve the best outcomes, such as the maximum profit or minimum profit, etc. Like whatever maximum or the minimum values in the mathematical model, whose requirements are represented by the linear relationships. In this given question, linear relationships. So in this question, the objective function is given to you as z is equal to ax plus by. Here we have been given that the feasible region of the geometric figure represented by the given objective function, the corner, or we can say the endpoints, have the maximum value, right? So according to the question, since the corner point have the same maximum value, all the point on the line also have the exact maximum value. Therefore, which are given to you over here as z of max. Thus, the number of points at which z max occurs is simply infinite. Option D is your correct answer. Hope you got that. Next question number 9, from the set of 1, 2, 3, 4, 5, two numbers A and B, where A and B both are not equal, are chosen at random. The probability A upon B is an integer is... The given set is 1, 2, 3, 4, 5. Therefore, the possible outcomes of A comma B will be equal to... Question number 9, from the set of 1, 2, 3, 4, 5, two numbers A and B are chosen at random. A and where A is not equal to B, the probability that A upon B is an integer is... The given set in this question is 1, 2, 3, 4, 5. So what are the possible outcomes for AB? Possible outcomes of A comma B are, like, it can be 1, 2, 1, 3. Because see, it is given that A is not equal to B, so I'm not choosing 1, 1, 1, 4, 1, 5. Then you have 2, 1, 2, 2, not 2, 2, sorry, it's 2, 3, 2, 4, and 2, 5. Right? Then you have here as 3, 1, 3, 2, 3, 4, 3, 5, 4, 1, 4, 2, 4, 3, 4, 5, and 5, 1, 5, 2, 5, 3, and 5, 4. So these are the possible outcomes, right? So how many are these? 1, 2, 3, 4, 5. So they are 20. Total 20 outcomes are there. Now, you have to find the probability that A upon B is an integer. A upon B is an integer. It happens in the cases of 2, 1, 3, 1, 4, 1, and 5, 1. So how many outcomes are there for total? There are, wait, there is one more. Wait. Yeah, after 4, 1, there is 4, 2 also, and 5, 1. So we have 5 outcomes for this, like the favorable outcomes, you can say. right? So the probability, required probability that A upon B is an integer becomes favorable cases, which are 5 upon the total cases, which are 20. That means 1 upon 4. This is the correct answer to the question, which makes option B to be the correct answer. Hope you got that. Let's move to the next question. Question number 10, a bag contains 3 white and 4 black, 2 red balls. So there are 3 white, 4 black, and 2 red balls. If 2 balls are drawn at random without replacement, then the probability that both the balls are white is. Fine. First of all, how many total balls are there in the bag? This is 9 balls total. Balls is equal to 9, and you have to withdraw 2 balls from the bag, and probability that both the balls are white. How many white balls are there? There are 3 white balls. Okay, so out of, you have to withdraw 2 balls. What is the probability of withdrawing 2 white balls? Okay, that will be the number of favorable cases, which is equal to 3C2, because out of 3 white you have to withdraw 2 white balls, divided by total balls are 9, C2. Out of 9 you have to withdraw 2 balls. So this is equal to 3 factorial upon 2 factorial into 1 factorial, multiply 2 factorial into 7 factorial upon 9 factorial. This is equal to 3 into 2 upon 9 into 8. This makes 3 and 4. That is equal to 1 by 12. So this is the answer to the question, and option C is the correct answer. Hope you understood that. Let's move to the next question. Number 11. So now in this 11 to 15, fill in the blanks with the correct sentence. Okay, fine. You have to find out the answer and fill in the blank. So the question is, if f is a function from real to real numbers be given by fx is equal to 3 minus x cube whole raised to power 1 by 3, then what is the value of f of x? This is what you need to find out. Okay, we are given fx is equal to this. Now, what will be the f of x? This will be f of fx. That means this is 3 minus fx raised to power 3, right? Whole raised to power 1 by 3, correct? This makes it 3 minus x cube raised to power 1 by 3 raised to power 3 raised to power 1 by 3. So this will be equal to 3 minus x raised to power 3, because this will be 3 into 1 by 3, which will cancel. Similarly, over here, this will be equal to 3 minus of 8. Yeah. Okay. So this will be 3 minus x cube raised to power 1 by 3. Right? Question number 11. From question number 11 to 15, you have to fill in the blanks with the correct answers. So the given question is, f is a function from real to real numbers be given by fx is equal to 3 minus x cube raised to power 1 by 3. Then you have to find f of x. Okay, so let's write. You have to find out f of x, which simply means f of the function fx, function of the function fx. This can be written as 3 minus fx raised to power 3 raised to power 1 by 3, right? So further, this is equal to 3 minus, now this is equal to 3 minus x cube raised to power 3 raised to power 1 by 3 raised to power 3 whole raised to power 1 by 3. I hope you got that. Okay, so this is equal to 3 minus x squared 1 by 3 into 3 raised to power 1 by 3. This 2 will cancel and you will have, sorry, not this bracket. 3 minus x cube whole raised to power 1 by 3. This will be equal to 3 minus 3 plus x cube raised to power 1 by 3. Now 3 and 3 again will cancel. You will be left with x cube raised to power 1 by 3, which will be equal to x only. That's it. You got your answer. So the f of x is nothing but the function, but the value, but the variable x. Right? Next is question number 12. Now matrix problem. If this is equal to this, then you have to find out the value of x and y product. Simply you have to find the value of x and y, and then you have to multiply them. Right? So from here, x plus y is equal to 2. 7 is equal to 7. 9 is equal to 9. And x minus y is equal to 4. Adding both of them, you will have 2x is equal to 6, or x is equal to 3. If x is equal to 3, then, sorry, this is 2. Then y will be equal to minus 1. So what is the product of x and y? This is equal to 3 into minus 1, which is equal to minus 3. Okay, so this is the answer to the question. Let's move to the next one. Question number 13. So the number of the points of discontinuity of f defined by this function is, you have to find out how many points this function is discontinuous. F of x is equal to mod of x minus mod of x plus 1. So the two given functions, let's say gx and hx, they will be defined as here is mod of x and x plus 1. Now this function is actually g minus h. The continuity of g and h is have to be examined first. So let's go for that. You're given, we have taken g of x is equal to mod of x. Now this can be written as g of x is equal to x if x is greater than 0, equal to 0, or this is equal to minus x if x is less than 0. Now clearly g is defined for all real numbers. G is defined for all real numbers. Let's see with the real number. Let C be a real number. So first case, if C is less than 0, then G of C will be equal to minus C, and limit G of x x approaching C will be equal to limit xc minus x. This is equal to minus C. Therefore, question number 13, the number of points of discontinuity of f defined by fx is equal to mod of x minus mod of x plus 1 is equal to dash. You are given fx is equal to mod of x minus mod of x plus 1, right? These two functions, let's say this is defined by g and h. So here gx is equal to mod of x, and hx is equal to mod of x plus 1, right? So f is equal to g minus h. The continuity of, let's examine the continuity of g and h first. So gx, I'll go with the g first. Gx is equal to mod of x. That means gx is equal to, it will be minus x if x is less than 0, and it will be positive x if x is greater than equal to 0. So clearly g is defined for all real numbers. Clearly g is defined for all real numbers. Let C be a real number. So first case, when C is negative, if C is less than 0, then G of C will be equal to minus C, and the limit x approaching c, gx is equal to limit x approaching c of minus x, that is equal to minus c. Therefore, limit x approaching c, g of x is equal to gc. Therefore, g is continuous at all points of x such that x is less than 0. Hence, g is continuous at all points x such that x is less than 0. Now, the second case, this is the first one. Let's take the second case. So, if c is greater than 0, c is positive, then g of c will be equal to c, and limit x approaching c, g x is equal to limit x approaching c, x only, right? And this is equal to c. Therefore, limit x approaching c, gx is equal to gc. Hence, g is continuous at all points x such that x is positive, right? Now, the third case, when c is 0, if c is equal to 0, then gc will be equal to g of 0, which is equal to 0. Hence, limit x approaching 0, g of x will be equal to limit x approaching 0 minus x, which is 0, and limit x approaching 0, g of x will be equal to limit x approaching 0, g of x, which is also 0. Therefore, g is continuous at x is equal to 0. From the above three observations, it can be concluded that g is continuous at all points, right? From the case 1, case 2, case 3, from all these cases, we conclude g is continuous at all the points, right? Hope you got that. So now let's move towards your hx. Hx was equal to mod of x plus 1. Now this can be written as hx is equal to minus of x plus 1 and plus of x plus 1. So minus of x plus 1 if c is less than 1 minus 1, and sorry, not c, x is less than minus 1, and when x is greater than minus 1. Right. Now clearly h is defined for every real number. Again, the same thing. H is defined for every real number. Let's see be a real number again. So three cases. First is when c is less than 1, then h of c will be minus c plus 1, and limit x approaching c, hx is equal to limit x approaching c minus of x plus 1. This is equal to minus of c plus 1. Therefore, limit x approaching c, h of x is equal to h of c. Hence, h is continuous at all points such that x is equal to x is less than minus 1. H is continuous at all points such that x is equal to x is less than minus 1. Right? Now, second case. When if c is greater than minus 1, then h of c is equal to c plus 1, and limit x approaching c, h x is equal to limit x approaching c, x plus 1, which is nothing but c plus 1. Therefore, limit x approaching c, h of x is equal to h of c. Hence, H is continuous at all points such that x is greater than -1. Okay. Now the last one, case 3, when C is equal to -1. C is equal to -1, then H of C will be equal to H of -1, which is equal to -1 plus 1, which is equal to 0. Therefore, limit x approaching -1, Hx is equal to limit x approaching -1 minus x plus 1 is equal to -1. Sorry, not. So this is -1 plus 1 minus of -1 plus 1. I'll rewrite this. Minus of -1 plus 1, which is again equal to 0. Limit x approaching -1. Hx is equal to limit x approaching -1. This will be x plus 1. Here was mod. We have already taken it. This is equal to -1 plus 1, which is 0. Therefore, limit x approaching -1, Hx is equal to limit x approaching -1, Hx is equal to h of -1. Okay. Therefore, h is continuous. At x is equal to -1. So from all the three observations, it can be seen that h is continuous. Okay, we have finished the page. So from all of them, from above observations, we conclude that h is continuous for this function. Right. Since g and h both are the continuous functions, so f was equal to g minus s. This is also continuous function. So f has, this is also continuous function. Right. So you were asked how many points of discontinuity are there? There are 0 points of discontinuity because both the functions g and h, they were continuous throughout. Okay. So the answer to the question is 0. Hope we got that. Let's move to the next question. Question number 14, the slope of the tangent to the curve y is equal to x cube minus x at the point 2, comma 6 is. This is such an easy question. Or the rate of change of the area of the circle with respect to the radius when r is equal to 3 centimeters is. So both are very easy questions. The A part says you, so, the curve is equal to y is equal to x cube minus x. Let's find out the differentiating both sides with respect to x. You have 3x square minus 1. So now the given point is 2, comma 6. So the slope, this actually represents the slope of the curve. So dy by dx at the point 2, comma 6 is given by 3 into 2 square minus 1, which is equal to 11. So 11 is the correct answer to the question. Next, B part, the rate of change of the area of the circle with respect to its radius when radius is 3 centimeters is equal to. So the area of the circle is given by pi r squared. Let's find out the derivative with respect to r. You have 2 pi r. Okay, now you have to find out the rate of change of the area with respect to radius for r is equal to 3. So this will give you 2 pi into 3, which is equal to 6 pi. So the answer is 6 pi centimeter square per centimeter because this is the rate of change of area with respect to radius. Hope you got both these questions. So this is 6 pi. Next is question number 15. Again, do you have a choice in this question? If A is a non-zero vector, then the dot product of AI into I plus AJ into J plus AK into K is equal to. Fine. Let's say A is equal to A1I, B1J, C1K. Therefore, AI into I plus AJ into J A K into K is equal to A1 I plus B1 J plus C1 K. Or this is simply C. Question number 15, if A is a non-zero vector, then the dot product of AI multiply I, AJ multiply J, AK multiply K equals to what? Okay, to solve the question, let's say first of all, let's say the A vector is equal to, this is equal to A1 I, A2 J, A3 K vector. Now, let's take dot product of A with I vector. So this will give you A vector. I is equal to A1, I, A2, J, A3, K, both having a dot product with I vector. This will be equal to A1 into I dot I, A2, J into I, A3, K into dot I. Okay. So, you know one thing that the dot product of two same vectors is equal to 1. The dot product of two different unit vectors is equal to 0 because angle between them is equal to 90 degree. Okay, similarly, J dot K is also equal to 0, right? Because angle between them is 90 degree and angle between them is 0 degree. And cos of 90 is equal to 0, cos of 0 is equal to 1. That's why. So this will evaluate to be A1 plus 0 plus 0 plus, right? This is A1. This is dot product of A and I, correct? Similarly, the dot product of A and J, similarly, you will solve dot product of A and J will give you A2. Dot product of A and K will give you A3, right? Now, what we had to find out in the question was, it was A dot I plus A dot J A dot K is equal to what? Right. We already got that is equal to A1. So A1 I, B1, sorry, A2 J, A3 K. And this is what? This is simply A vector. We have assumed this thing in the beginning. Right. So the answer to the question is A vector itself. Hope you got that. Let's move to the next question then. Question number, sorry, B part of this, B choice of this question. The projection of the vector I minus j on the vector I plus j is equal to. Okay, B part, let's see. A is I minus j and B is I plus j. Now, projection of vector A and B is given by 1 upon mod of B into the dot product of A and B, right? So this is equal to 1 upon root of 1 plus 1, 1 square plus 1 square, which is 1 plus 1 into A and B. Let's find out their dot product. So this is equal to 1 dot 1 plus minus 1 into 1. Okay, so this is 1 by root 2, 1 minus 1. That's equal to 0. So projection of A on B is equal to 0. Simple as that. I've always seen the B part, like so many videos I have made, I've already seen that B part is much easier than the A part, but don't take it like for sure. This is just a recommendation. Let's move to the next question, number 16. So question number 16 to 20, they are very short questions. You have to find out the adjoint of A. A is a square matrix of order 2. Such matrices, the finding out the adjoint is very easy. See, what happens is, this is a general one I'm saying. First row, first column, first row, second column, second row, first column, and second row, second column. So you can find out the adjoint using this way, right? I'll interchange the positions of A1 and A2. and interchange their signs. Okay, so that's it. Here, I'll interchange the positions of 3 and 2, and I'll interchange the sign of these two places. So that's it. It was pretty easy. Just have to remember this thing, right? So this is the answer to the question. Hope you got that. Next is question number 17. So you have to find the integral of 2x raised to power 1 minus 5x raised to power minus 1 divided by 10 raised to power x dx. So let's split it up. This can be written as 2x raised to power 2 raised to power x plus 1 divided by 10 raised to power x into dx. And this can be written as 5, wait, 5 raised to power x minus 1 upon 10 raised to power x into dx. So this will be 2 raised to power x, 10 raised to power x dx, and I'll take 1 by 5 here. 5 raised to power x, 10 raised to power x dx. So this will give me 2 will be here, integral of 1 upon 5 raised to power x dx minus 1 upon 5, 1 upon 2 raised to power x dx. Hope you understood till here. Okay. So this becomes a 2 integral of 5 raised to power minus x dx minus 1 by 5 integral of 2 raised to power minus x dx. Okay. This is equal to 2 raised to power, 2 into 5 raised to power minus 6 divided by log of 5 multiply this minus 1 by 5, 2 raised to power minus x divided by log of 2 into 1 upon minus 1 plus c. So this makes it minus 2 upon 5 raised to power x log of 5 plus 1 upon 5 into 2 raised to power x log of 2 plus c. So this is the answer to the question. Hope you got that. Next is question number 80. So again, an integral problem, you have to find out the integral of 0 to 2 pi mod of sine x. So this is 0 to 2 pi mod of sine x dx, right? This can be written as 0 to pi. It will be sine positive sine x dx minus pi to 2 pi minus, I already have taken outside. So this is again sine x dx. Okay. So that is equal to, what is the integral of sine x? It's minus cos x minus, I have taken outside, 0 to pi minus minus plus cos x pi to 2 pi. Okay. So this makes minus cos of pi minus cos of 0 plus cos 2 pi minus cos of pi. So this makes it minus cos of pi is equal to minus 1 plus cos 2 pi is 1 minus of minus 1 will be plus 1. Okay. This makes it 2 plus 2, that is equal to 4. So the answer to this question is equal to 4. Hope you understood that. Next is question number 19. You have to find the integral of dx upon 1 plus 4x square. What you have to find out? You have to find out the value of a. You are given that this is equal to pi by 8. Limits are from 0 to a. Fine. Okay, so let's go with this. Now this can be written as 4x square can be written as 0 to a dx 1 square plus 2x square. This is equal to pi by 8. This is the integral for this. See, tan inverse x is equal to 1 upon 1 plus x square, right? So this is the tan inverse of 2x. Limits 0 to a. This is equal to pi by 8, right? So half of tan inverse to a minus tangent inverse of 0 is equal to pi by 8. Or you have tangent inverse of 2a minus 0 is equal to pi by 4. You know, this is equal to 2a is equal to tangent of pi by 4, that is equal to 1, which gives you a as 1 by 2. So that is the answer to the question. A is equal to 1 by 2. Hope you got that. Now let's move to the second part of this question. You have to find out the integral of, let's With the B part, we have to find the integral of dx upon the root of x plus x. This is, let's say this is equal to I. Now this is equal to integral of 1 upon root of x, 1 plus root of x dx. Let's put root of x is equal to t. Then finding derivative on both the sides, 1 upon 2 into root x into dx is equal to dt. Or this is equal to 2 dt. So what does our integral become now? So integral will become 2 into 1 upon 1 plus t into dt, which simply the finding integral is very easy now. So this is equal to 2 into 1 plus log of 1 plus t plus c. So this is 2 log of 1 plus root of x plus c. This is the answer to the question. Hope you got that as well. Let's move to the next question then. Question number 20. Show that the function y is equal to ax plus 2a square is a solution of the differential equation this. Okay, so basically we should write this equation. 2 into dy by dx whole square plus x into dy by dx is equal to 0. All right. Okay, I'll start with this one only. It's better because here I have to find out and like I have to do the integral twice. So it's better to pick up this equation y is equal to ax plus 2a square. Let's differentiate both sides with respect to x. So dy by dx will be equal to a simply plus 0, which is equal to a. Now substituting a in this equation. Question number 20, show that the function y is equal to ax plus 2a square is a solution of this differential equation. Given function is y is equal to ax plus 2a square. Let's differentiate both the sides with respect to x. You will have a into 1 plus 0, which is equal to a. So that means a is equal to dy by dx. Let's fill in this equation. Okay. So you will have y is equal to, if I say from 1, y is equal to dy by dx into a plus, sorry, into x plus 2 into dy by dx whole square. Right. Now, if I rewrite this properly, this will be 2 into dy by dx whole square plus x into dy by dx minus y is equal to 0. So this is exactly what the equation was, hence proved, right? We had to show that this is a solution of this differential equation. We found out the value of a from here and we substituted back into the equation. We got this equation, hence proved. Let's move to the next question, number 21. So this question says you from 21 to 26, they are carrying 2 marks. So bit lengthy questions. Now you have to check if the relation R on this set is defined as R is equal to xy such that y is divisible by x. This is symmetric or transitive. Or you have the second part as well. You can do any of these. Let's go with the A part first. So here you are given the set A as 1, 2, 3, 4, 5, and 6. So R is equal to x comma y such that y is divisible by x, right? So what does that become? First of all, y is divisible by x. So the very first one is 4 comma 2. Wait, it's not 4 comma 2, it's 2 comma 4. See, y is divisible by x. So the very first one is 4 comma 2. Right now this belongs to the this relation because 4 is divisible by 2, right? But here, if I say 4 comma 2, it does not belong to the set R. Why? Because 2 is not divisible by 4, right? Right. Therefore, this relation is not symmetric. Now, we are out of the first option. Let's check with the transitive. So I'll say let B part of it, or you can say second part of it. This was the first part. Okay. So the second part of it is let A, comma B belong to R and B, comma C belong to R. Let's say B is equal to lambda A and C is equal to mu B. Now C is equal to mu B, or this is equal to mu of lambda of A. This says that A, comma C belongs to R. This makes C to be divisible by C is, this implies that C is divisible by A, right? Hence, R is transitive. This relation is transitive relation. Hope you understood that. Let's move to the B part of it. You have a choice in the question. You have to prove that this statement is true, right? Let's write down the statement first. So you are given, you have to prove 9 pi by 8 minus 9 by 4 sine inverse 1 by 3. 9 by 4, this is equal to 9 by 4 sine inverse this. Okay, it's 9 by 4 sine inverse 2. Let's write it down. This is equal to 9 by 4 sine inverse 2 root 2 upon this. This is to prove. Now let's go towards the proof. Here is your LHS 9 pi by 8 minus 9 by 4 sine inverse of 1 by 3. This can be written as, I'll take the 9 by 4 common from here. This will be pi by 2 minus sine inverse 1 by 3. This is equal to 9 by 4 cos inverse 1 by 3. Now, why is that? Because pi by 2 minus sine inverse of x is equal to cos inverse of x, right? So, similarly, using that, this is true. Uh, Fine. I hope you are clear till this. Now, let's say cos inverse 1 by 3 is equal to x. Then, cos of x will be equal to 1 by 3, right? And this is equal to, if I convert into sine, so this will be sine of. Let's move with the B part of this question now. You have to prove that this statement is true. Let's write on the B part. Here is 9 pi by 8 minus 9 pi 9 by 4 sine inverse 1 by 3 is equal to 9 by 4 sine inverse of 2 root 2 upon 3. This is to prove. Let's go with the proof now. So I'm going with the proof. Let's go with the LHS. You have 9 pi by 8 minus 9 by 4 sine inverse 1 by 3. I'm taking 9 by 4 common. So this is equal to pi by 2 minus sine inverse 1 by 3. All right. Now there's a formula. This is pi by 2 minus sine inverse 1 by 3 is equal to cos sine inverse x is equal to cos inverse of x. Okay. So this is 9 by 4 cos inverse of 1 by 3. Correct. Now, see, let's say cos inverse 1 by 3 is equal to x, which makes cos x is equal to 1 by 3. If cos x is equal to 1 by 3, sine x will be equal to 1 minus 1 by 3 square, which is equal to root of 9 minus 1 upon 9, right? Which is root of 8 upon 9, that is 2 root 2 upon 3, right? This is sine of x, or x is equal to sine inverse of this, correct? Fine. So let's put this back over here. Yeah, in this equation in 1. Let's put. So from 1, what do you have was, we had 9 by 4 LHS. This was your LHS 9 by 4 cos inverse 1 by 3, which we already took 9 by 4 into x, and x was solved as sine inverse 2 root 2 upon 3. And this is your RHS, right? Hence proved. Hope you understood that. Let's move to the next. 22nd question of this paper. So in this question, you have to find the value of dy by dx at theta is equal to pi by 3. If x is equal to cos theta minus cos 2 theta and y is equal to sin theta minus sin 2 theta. Okay, so you are given x is equal to cos theta minus cos 2 theta, or dx upon d theta is equal to minus sin theta plus 2 sin 2 theta. Also, you have y is equal to sin theta minus sin 2 theta, or dy by d theta is equal to cos theta minus 2 cos theta. You had to find out dy by dx. This is simply equal to dy by d theta upon dx by d theta. And what was that? This is equal to cos theta minus cos 2 theta whole divided by minus sin theta plus 2 sin 2 theta. Or I can write it as like cos theta minus 2 cos 2 theta whole divided by 2 sin 2 theta minus sin theta. Now you have to find out dy by dx at pi by 3. So dy by dx at theta is equal to pi by 3 is given by cos of pi by 3 minus 2 cos 2 pi by 3 divided by 2 sin 2 pi by 3 minus sin pi by 3. Right? What is the value of cos pi by 3? This is cos of 60. That is equal to 1 by 2 minus 2 into minus 1 by 2 whole divided by, this is 2 into sine of 120, which will be equal to sine of minus 60. And yeah, sine of this will be equal to root 3 by 2. Okay, minus root 3 by 2. So this becomes 1 by 2 plus 1 divided by 3. No, 3, sorry. This is root of 3 minus root of 3 upon 2. This is equal to 3 by 2 and this is equal to root 3 by 2. 2 and 2 will get cancelled and you will have 3 upon root 3, which gives you root 3 as the answer. Hope you understood that, right? So the answer to this question, you have to find the value of dy by d theta at theta is equal to pi by 3, and the answer to this question is equal to root 3. Hope you understood. Let's move to the next question then. Question number 23, you have to show that the function f defined by fx is equal to x minus 1 into e raised to power x plus 1 is an increasing function for the all positive values of x. Okay, since we are talking about the increasing or the decreasing function, I have to find out the derivative of this function. This is equal to x minus 1 into e raised to power x plus e raised to power x into the derivative of x minus 1. That's 1 plus 0. So this becomes e raised to power x. I'll take common x minus 1 plus 1. This is equal to x into e raised to power x, which is greater than 0 for all x greater than 0. Therefore, f dash x is an increasing function. Fx is an increasing function for all x greater than 0. Hope you understood that. Next question number 24. Again, you have a choice in the question. You have to find the magnitude of a and b vector. If a is equal to magnitude of a vector is twice the magnitude of b vector, and the dot product of these two vectors is equal to 12. Or you have a choice in the question. You can go for the b part as well. I'll go with the first one. A part. First of all, you are given that the magnitude of a vector is twice the magnitude of b vector, and the dot product of a plus b and a minus b vector is equal to 12, right? Since they are the dot, and these two vectors, their dot product will be equal to the square of magnitude of a minus square of magnitude of b. That's equal to this. And you know this is equal to twice square of magnitude of b minus this. This is equal to 12. This gives you 4 magnitude of b vector square minus magnitude of b vector square is equal to 12. This gives you 3 magnitude of b vector 12 magnitude of b vector squared is equal to 12. Or from here, this will cancel at 4, or you will have the magnitude of b vector as equal to 2, right? Hope you got this, right? And then a vector will be equal to 4, right? And this is what you needed to find out in the question, the magnitude of a vector and the b vector. This is the answer to the question. Hope you got that. Let's move to the next question, number 25. You have to find the equation of the plane with the intercept 3 on the y-axis and parallel to the xz plane. Okay. So here you are given that sorry, one thing I missed doing this part. Sorry. I'll just finish with this one also. So here's the B part. A vector is given by 4i plus 3j plus k, and B is 2i minus j plus 2k, right? You have to find out the unit vector perpendicular to these vectors. For that, let's find out the cross product of these two vectors first. This is equal to I, j, and k. So this is 4, 3, 1, 2, minus 1, and 2. That's equal to I 6 plus 1 minus j 8 minus 6, k minus 4 minus 6. This will give the vector as 7, I 6. Wait, I have done some. Here was supposed to be 2. Okay, so this is minus 6j minus 10k. Now the unit vector perpendicular to both of them, unit vector perpendicular to both A and B vector is equal to plus minus the cross product of these two vectors divided by the magnitude of the cross product. So this is equal to 7i minus 6j minus 10k whole divided by root of 7 square minus 6 square plus minus 10 square. Here is plus minus, right? That's equal to plus minus 7i minus 6j minus 10k. This is root of 49, 36, and 100. So this is plus minus 7i minus 6j minus 10k whole divided by root of 185. This is the answer to the question. Hope you got that. Then let's move to the next question. Question number 25, we have to find the equation of the plane with the intercept 3 on the y-axis and parallel to the xz plane. See, there are actually two ways to do the sum. I'll go with the easy one. This is a 2 marks question. So not a very lengthy one. So I'll go with the easier one. See, it's always better to go with the easy one. So you're given that the plane is parallel to xz plane. It's given that plane is parallel to xz plane. So the required equation can be y is equal to k, right? Now from it's given that the plane makes an intercept of 3 units on the y-axis. So that means it passes through the point 30, 030, right? Further, plane have an intercept of 3 units on y-axis, right? Therefore, it must pass through 303. So that means over here, what is the value of k? 3. That means y is equal to 3. This is the equation of the plane, simple as that, right? Hope you understood that. Let's move to the next question, number 26. So you have to find the probability B upon A plus probability A upon B. If PA is this, PB is this, and PA union B is this. So you are given actually everything in the question. It's pretty easy to go. You are given PA union B. You know this formula. Let's write down the formula first. That's equal to PA plus PB minus PA intersection B. That is equal to 3 by 5. This is equal to 3 by 10 plus 2 by 5 minus P A intersection B, or B A intersection B is equal to 3 upon 10, 2 plus 2 upon 5 minus 3 upon 5. I'll take the LCM. So this will be 3 plus 4 minus 6, which will be equal to 1 upon 10. This is the probability of both the events to happen. Right. Now you have to find out to find is PB upon A plus PA upon B. This is equal to PA upon B divided by P of A plus PA upon PA intersection B divided by PD. Right. So this is 1 by 10 divided by 3 upon 10, 1 upon 10 divided by 2 upon 5, which will be 1 by 3 plus this will be 1 by 4. So the answer will be 7 by 12. Hope you understood that. Let's move to the next question with 27. So now you are going to have very lengthy questions. 27 to 32, they are going to carry 4 marks. We have to, the first section question, we have to prove that the relation R on Z defined by R, X, Y such that X minus Y is divisible by 5 is an equivalence relation. Okay. See, R on Z is, let's write it first, defined as R is XY, the set of ordered pair XY such that X minus Y is divisible by 5. Right? Now for reflexive, we have to check for the reflexive. Let's say X belongs to Z, and then X minus X will be equal to 0, which is divisible by 5. First case, which is divisible by 5. So that means X comma X minus R for all X belonging to Z. Hence, R is a reflexive function. Correct? Because this is possible. Sorry, reflexive, it's relation. Okay. Now, let's go for checking the symmetry of it. For symmetric, let's say, let X comma Y belongs to this set R. Then the condition is X minus Y is divisible by 5. Right? If this is divisible by 5, then this is also divisible by 5. Correct? That means Y minus X is also divisible by 5. Y comma X also belongs to R. Therefore, R is symmetric as well. Right? Now let's check for the transitive. Let's say X comma Y belong to R, and Y comma Z also belongs to R. Then X minus Y and Y minus Z, they are divisible by 5, which means X minus Y plus Y minus Z is also divisible by 5. Which means X minus Y, X minus Z is also divisible by 5, and X comma Z, they belongs to this relation R. Therefore, R is transitive also. Therefore, it's all the three. It is transitive, it is symmetric, it is reflexive. Therefore, R is a R is an equivalence relation. Hope you understood that. And this is what we needed to prove in the question, and we proved it, hence proved. Hope you understood that. Next is question number 28. Again, we have a choice in this question. The first part is if y is equal to sine inverse of this expression, then show that dy by dx is equal to minus 1 upon 2 into 1 upon x squared under the root. I'll go with the first part first. We are given y is equal to sine inverse root of 1 plus x root of 1 minus x divided by 2. Right. So first thing, I'll put x is equal to cos 2 theta. So y will become, it will become sine inverse 1 plus cos 2 theta under the root plus 1 minus cos 2 theta whole thing divided by 2. So now you know this is equal to 2 cos square theta up, sorry, it's inside the root. So this is equal to 2 cos square theta plus this is equal to 2 sine square theta upon 2. Sine inverse of root 2 will be taken outside and this, and we have sine theta plus cos theta over here. Okay. Fine. So now this will be equal to sine inverse. Question number 28, if y is equal to sine inverse this expression, then show that dy by dx is equal to this. Or you can do the sum, verify the Rolle's theorem for this given function in this given interval. Okay, so start with question number 1. You are given y is equal to sine inverse root of 1 plus x plus root of 1 minus x whole divided by 2. Let's do this thing. I'm putting x is equal to cos 2 theta. From here, theta will be equal to cos inverse x upon 2, right? Now let's get back to our y. So y will be equal to sine inverse root of 1 plus cos 2 theta plus root of 1 minus cos 2 theta whole divided by 2. You know 1 plus cos 2 theta, this is equal to 2 cos square theta, and this is equal to 2 sine square theta whole divided by 2. Correct? So you have sine inverse root 2 will be taken common. This will be cos theta plus sine theta whole divided by 2. That gives you sine inverse 1 by root 2, or you can say cos theta upon root 2 plus sine theta upon root 2. Right? And you know 1 by root 2 is the value for sine pi by 4. So I can write it as sine pi by 4 into cos theta. And 1 by 2 root 2 is also the value for cos pi by 4. So I can write it as cos pi by 4 into sine theta. This is the formula for sine A plus B. So this is sine inverse sine A plus B, which is equal to pi by 4 plus theta. Or this will be equal to, y will be equal to pi by 4 plus theta, because sine inverse and sine, they will cancel out each other. Okay. Okay. Also, let's find out now the derivative, differentiating both sides with respect to theta. You have dy by d theta is equal to 0 plus 1, or dy by d theta is equal to 1. Let's get back to our question. Here you had the theta as cos inverse x by 2. Now, you had theta as cos inverse x upon 2, or d theta upon dx is equal to, let's find out the derivative. So this is equal to 1 by 2 into this root of 1 minus x squared, 1 upon, right? Now you actually have to find out in the question was dy by dx. Now, to find was dy by dx. This can be written as dy upon d theta multiply d theta upon dx. Correct. So this is equal to 1 and this is equal to 1 upon 2 root of 1 minus x square. Right? This can be written as 1 upon 2 root of 1 minus x square. That's it. We got our answer, I think. Yes. Okay. One thing, sorry. One mistake I have done over here. This will be minus 1, right? Because this is cos inverse. Here is minus 1 and here is minus 1. So that's it, right? So this is this is what we needed to prove. So this is hence proved. Hope you understood that. Next, not next, we still have to go for the second part of this question. This is part B. Let's go. You have to verify the Rolle's theorem for the function fx is equal to e raised to power x cos x. So now we know that the exponential and the cosine functions are continuous and differentiable on R, on all the real numbers, right? Therefore, let's write this thing. Exponential and cosine functions are continuous and differentiable on R. Let's find the values of the function. Let's find values of the function at extreme. Okay, therefore, what was the extremes? Minus pi by 2 and pi by 2. So f of minus pi by 2 will be equal to e raised to power minus pi by 2 into cos of minus pi by 2, or f of minus pi by 2 is equal to e raised to power minus pi by 2 into 0, because cos of pi by 2 is equal to 0. This is equal to 0 simply. Let's go for f of pi by 2. Let's say this is 1. F of pi by 2 is equal to e raised to power pi by 2 into cos of pi by 2, which is equal to e raised to power pi by 2 multiply 0, or this is also equal to 0. Let's say this is 2. Okay, so we have f of pi by 2 is equal to f of minus pi by 2. Therefore, there exists, therefore, there exists a constant or a term c which is belonging to this interval pi by 2 minus pi by 2 to pi by 2 such that f dash c is equal to 0, right? Now let's find out the derivative of this function. The function was e raised to power x cos of x. So the derivative will be equal to first function into derivative of second plus second function into derivative of first. So here will be e raised to power x cos x minus sin x. Here f dash, this is f c. Here f dash c is equal to 0. So that means e raised to power c minus sin c plus cos c is equal to 0, or sin c minus sin c plus cos c is equal to 0, or you can say dividing both sides by root 2, you will have minus 1 by root 2 sin c plus 1 by root 2 cos c is equal to 0. Minus 1 by root 2, this can be written as minus of sin pi by 4 sin c plus cos pi by 4 into cos c is equal to 0. This is the formula for cos a plus b, because this is cos a cos b minus sin a sin b. This is the formula for cos a plus b. This is equal to 0, or c plus c. This is equal to 0. Cos of c plus pi by 4. This is equal to 0 at when cos is equal to pi by 2. So that means c plus pi by 4 is equal to pi by 2, or c is equal to pi by 2 minus pi by 4, which is equal to pi by 4. Okay, now this pi by 4, this belongs to minus pi in the interval minus pi by 2 to pi by 2. Therefore, your Rolle's theorem is verified. Rolle's theorem is verified. Hope you understood that. Let's move to the next question then. Number 29, you have to evaluate the integral 0 to pi x sine x upon 1 plus cos square x dx. Let's say this is equal to I. So here I'll be using one formula, that is 0 to pi f x, if I say here 0 to a, fx dx is equal to integral 0 to a f of a minus x dx. So now this I will be equal to, x will be converted into pi minus x integral 0 to pi sine of pi minus x whole divided by 1 plus cos square pi minus x dx. So this I now is equal to integral 0 to pi minus x sine pi minus x is equal to sine x only, and 1 plus cos square x pi minus x will be equal to cos square x only dx. Now let's say this is equation 2 and this one as equation 1, adding 1 and 2, adding 1 and 2, you will get 2I is equal to 0 to pi. That was, yeah. So I'll take the LCM itself, 1 plus cos square x, x sine x plus pi minus x sine x dx, right? So x sine x will cancel out. You will have here x sine x plus pi sine x minus x sine x whole divided by 1 plus cos square x dx. These two will cancel out. The limits were from 0 to pi. So this is equal to, I'll take the pi outside, pi integral 0 to pi sine x upon 1 plus cos square x dx. Now let's put t is equal to cos x, or dt will be equal to minus sin x dx. So now at x is equal to 0, t will be equal to 1, and yeah, and at x is equal to pi, t will be equal to minus 1. That means your I now will become limit from, this was pi, from 1 to minus 1 minus dt upon 1 plus t square. I'll take this 2 down. Okay. Yeah. See, this 2 is from here because that was equal to your 2I. This was equal to your 2I. So I is equal to pi upon 2, right? That's it. So now this is the formula for minus pi by 2. This is the formula for tangent inverse of t, limits from 1 to minus 1. So this is equal to minus pi by 2 tangent inverse of minus 1 minus tangent inverse of 1 minus pi by 2. This is equal to minus pi by 4 minus pi by 4, which is equal to minus pi by 2 into minus pi by 2. That will be equal to pi square upon 4. So this is the answer to the question. Hope you understood that. So the answer is my pi square upon 4. Hope you understood that. Let's move to the next question, number 30. For the differential equation given below, find a particular solution satisfying the given equation. Okay, there's a misprint over here. The given correct question is x plus 1 into dy by dx is equal to 2 e raised to power minus y plus 1. Y is equal to 0, given that y is equal to 0 when x is equal to 0. Now I'll start with the solution from here. You are given x plus 1 into dy by dx is equal to 2 upon e raised to power y plus 1. You are given y is equal to 0 when x is equal to 0, or x plus 1 dy by dx. I'm taking the LCM. This will be 2 plus e raised to power y upon e raised to power y. So now taking Okay, I'll do one more thing. I'll take this e raised to power y on this side. So e raised to power y upon 2 plus e raised to power y into dy is equal to 1 upon x plus 1 into dx. Let's take the integral on both the sides now. So I'll say now e raised to power y plus 2. Let's say this is equal to t. So e raised to power y dy is equal to dt. So this integral I now will say, let's say this is equal to I, and this integral now will become 1 upon t dt is equal to dx upon x plus 1. So this is log t is equal to log x plus 1 plus log c, or log of e raised to power y plus 2 is equal to log of c into x plus 1 under the mod, right? So that means e raised to power y plus 2 is equal to c into x plus 1. Now let's put x is equal to 0 and y is equal to 0, you will have e raised to power 0 plus 2 is equal to c into 0 plus 1, or 3, because e raised to power 0 is equal to 1, 1 plus 2 is equal to 3, that's equal to c. We got the value of c as 3. Now let's put that in this equation. You have e raised to power y plus 2 is equal to 3 into x raised to x plus 1, or this will be equal to e raised to power y is equal to 3x plus 1. Yeah, so this is the answer to the question. Hope you understood that. Let's see. Yeah. Okay, then let's move to the next question. Question number 31. A manufacturer has 3 machines, 1, 2, 3, installed in his factory. Machine 1 and 2 are capable of being operated for about 12 hours, whereas 3 must be operated for at least 5 hours a day. He produces only 2 items, M and N, each requiring the use of all 3 machines. The number of hours required for producing 1 unit of M and N on 3 machines are given in the following table. So M machine 1, it needs to be worked for 1 hour, 2 needs to be worked for 2 hours, and 3 needs to work for 1 hour at least. Similarly, this is the time for 1 to 3 machine for the part or for the item N. Now it says he makes a profit of 600 and 400 on 1 unit of M and N respectively. How many units of each item should he produce so as to maximize his profit, assuming that he can sell all the items that he produced? What will be the maximum profit? Okay, so first of all, let not Mn, we are given Mn already. So I'll say let X and Y be the number of M and N items respectively. Total profit on production will be rupees 600 for M and 400 for N. Now, mathematical formulation of this problem is you have to maximize Z is equal to 600x plus 400y subject to constraints. So you are given constraints that x plus 2y should be less than equal to 12. Constraint on machine 1. See from here, it is said 1 and 2 are capable of being operated at most 12 hours. So here X is working for 1 and N is working for 2 hours for one product of M and N respectively. Similarly, the second constraint is 2x plus y should be less than 12. This is for constraint on machine 2. Third constraint is x plus 54 y should be greater than equal to 5. This is constraint on wait. Okay. This is constraint on machine 3. This is actually 5 by 4 because here it was 1.25 which is equal to 5 upon 4. Okay, now let's we have all the three constraints. One more thing, that x and y both are greater than equal to 0. These are the four constraints. Right. Now let's change these inequalities to equalities. You have the first one, x plus 2y is equal to 12. 2x plus y is equal to 12. And x plus 5 by 4y is equal to 5. Okay. Let's draw. For drawing the graph, let's have the points first. So this is xy. This is again xy and xy. So here, when I put x is equal to 0, y comes out to be 6. And when I put y is equal to 0, x comes out to be 12. And similarly here, when x is 0, y is equal to 12. And when y is 0, x is 6. From here, when x is 0, y comes to be 4. Right? When x is equal to 0, y is equal to definitely 4. And when y is equal to 0, x is equal to 5. Okay, we got the points. Now let's plot the graph for these three lines. Okay, I have to go to 12, so it's going to be a bit lengthy one. I'll try to accommodate on the screen itself. So here we go. This is, I'll take the scale of 2. So this is 2, 4, 6, 8, 10, and 12. Similarly here, 2, 4, 6, 8, 10, and 12. Correct. Now let's plot the points. Here you had the first point 0, 6 and 12, 0. So this is the point 12, 0. And this is a point 0, 6. So this is the line. This is the line x plus 2y is equal to 12. Second one, you have a 0, 12 and 6, 0. So here is 6, 0 and 0, 12, which is this point. Okay, now let's join them. It's not a straight line actually. I'll try to make a straight line. So here is the straight line. Okay, fine. So this is the line 2x plus y is equal to 12. Now let's make the third line. 0, 4 and 5, 0. So here is the 5, sorry, here is the 5, 0 point and 0, 4. It is at this point, right? So this is the line again. This will be somewhat like this. Okay. So this line will go somewhere like this. Okay, this is the line x plus 5 by 4y is equal to 5. Right. Okay, fine. Now you have to, let's find out the point of intersection. This point, when you will plot on the graph, this will be 4, 4. Let's say this is O, this is A, this is 5, 0. This is B, 6, 0. That's C. I'm saying that C. 4, 4, and this is D, which is 0, 6. Let's say this is equal to E, which is 0, 4. All right. Okay. So this is a shaded part. Now let's get back to our question. What we had to find out, definitely we have to maximize the profit. So these are the 4 points, 5 points rather, A, B, C, D, E. These are the 5 feasible regions and the shaded region is given over here. So now these are the 5 points. Let's see its maximum at which points. It is, let's say, Z was equal to 600x plus 400y for the first point A, which is 5, 0. A, which is 5, 0. Z is equal to 600 into 5 plus 400 into 0, which is equal to 3000. And for the point B, which is 6, 0, Z is equal to 3600 For the point C, which was 4, 4, D point was 0, 6, E point was 0, 4. So all of them, this value of Z here is 400 into 4. This will be 36 plus 16,000, which is equal to 24 plus 16,000, which is equal to 4,000 rupees. All these are rupees. And this is equal to 600 into 0, 400 into 6, which is 2,400 rupees. This is equal to 600 into 0, 400 into 4, which is equal to 1,600 rupees. So this is the maximum profit, right? We see that the point 4, 4 is giving us the maximum profit or maximum value of Z. And hence the manufacturer has to produce 4 units of each item to get the maximum profit. Okay. So that means 4 units of M and 4 units of N needs to be produced to get the maximum profit on this deal. Hope you understood that. Let's move to the next question, number 32. So a coin is biased so that the head is 3 times as likely to occur as the tail. If the coin is twice, find the probability distribution of the number of tails, hence find the mean of the number of tails. Fine. Here you are given coin is biased so that the head is 3 times as likely as to occur as the tail. So that means probability of getting a head is 3 times the probability of getting the tail. And you know one thing, the probability of getting the head plus the tail, this is equal to 1. That means 3 probability of tail plus probability of tail is equal to 1, or 4 probability of getting the tail is equal to 1, or the probability of getting the tail is equal to 0.25. That is equal to 1 by 4, right? Or I'll simply write this as 1 by 4 only. Okay, that means the probability of getting the head is equal to 3 times the probability of getting the tail, that is equal to 3 by 4. Now let X denote number of tails obtained when coin is tossed twice. That means X can be equal to 0, 1 or 2. So when X is 0, that means you're getting both the heads, head and head. That means this is equal to 3 by 4 to 3 by 4, which is equal to 3 by 4 squared. That is equal to 9 by 16. Probability of getting one tail, this is equal to 0. Okay. So probability of getting one tail, this may be head tail or tail head, both of them. That means this is equal to 3 by 4 into 1 by 4 plus 1 by 4 into 3 by 4, which is equal to 3 by 16 plus 3 by 16, or this is equal to 6 by 16 also. Now the probability of getting two heads, two tails. This is equal to probability of getting the tail and tail, which is surely 1 by 4 into 1 by 4, which is equal to 1 by 16. Now let's make the probability distribution table. This is the table when this is X and this is P of Xi. Let's say this is I for 0, 1 and 2. This is 9 by 16. This is 6 by 16. This is 1 by 16. Now we got the probability distribution table, right? Also, we have to find the probability distribution. We got that. We also have to find the mean of the number of tails. So mean is given by E of X, that is equal to summation I from 1 to N Xi into P Xi, which is equal to 0. See, 0 into 9 upon 16, 1 into 6 upon 16, 2 into 1 upon 16, which is equal to 6 upon 16 plus 2 upon 16, which is 8 upon 16, or that is equal to 1 by 2. So we got the mean as well, right? This is equal to 1 by 2. Hope you understood that. Let's move to the B part of the same question. Or the option, suppose that I'll erase. Suppose that 5 men out of 100 and 25 women out of 1000 are good orators. Assuming that there are equal number of men and women, you have to find the probability of choosing a good orator. Okay. Let's say E1 be the event of selecting a man. Wait. And E2 be the event of selecting a woman. Now, A be the event of selecting a good orator. Of selecting good orator. Then the probability of E1 is equal to probability of E2, and that is equal to 1 by 2. Why? Because number of men and women are equal. Number of men and women are equal. Also, probability of choosing a good orator from men is equal to 5 upon 100. It's given here. See, every 5 out of 100 men are good orators, and every 25 out of 1000 women are good orators. That means the probability of A upon E2 is equal to 25 upon 1000, which is equal to 1 by 40, and this is equal to 1 by 20. Now, hope you're clear till here. So, by total theorem of probability, you have probability of choosing a good orator is equal to PE1 multiply PA upon E1 plus PE2 multiply PA upon E2. This is equal to 1 by 2 into 1 by 20 plus 1 by 2 into 1 by 40, 1 by 40, 1 by 80, or this is equal to 3 by 80. So this is the correct answer to the question. Hope you understood that. Let's move to the next question number 33. Now we are moving to the section D, which are going to carry the 6 marks. That means they are going to be very important in the lengthy questions. Let's go. So using the property of determinants, you have to prove that this is equal to this. This is a very basic question you must have solved during your practice times number of times. So here we go with this question. A very best of luck. I hope already you know this. Let's start. Let's say A is equal to, that was okay, AB, wait, determinant it is, wait. So you have A minus B, B plus C, A, B minus C minus A, C plus A plus B and C. Now applying some transformations, C1 as C1 minus C3. And C2 as C2 plus C3. So now this will become, after applying these transformations, this will become A minus B minus A. This will be minus B minus C minus A. Now this will be B, A plus B plus C. Similarly, A plus B plus C, A plus B plus C. Here you have A, B, C only, right? So I'm going to take two things common, -1 and this A plus B plus C, right? So after that, you will have a B, C, A over here, 1, 1, 1, A, B, and C. Now taking -1 common from C1 over here, what I've done is I've taken -1 common from here and ABC common from here, right? Now I'll do some more transformations now. I'll be doing R2 to R2 minus R1 and R3 to R3 minus R1 again. Okay, so this will be equal to now B 1, A. Then you have C minus B. Here you have A minus B, this will be 0, 0. Here you will have B minus A, and here you will have C minus A. Now, see, we got these two terms 0. That means I'll be expanding. I'll be trying to expand this whole question from here. One thing I forgot to write over here was minus 1, A plus B plus C. So minus 1, I'm going to solve the determinant now. A plus B plus C. Now I'm going to expand for this 1. So this will be equal to minus of minus B, C minus B into C minus A plus B minus A into A minus B brackets close. This is equal to minus 1A plus B plus C brackets close. You have minus C square plus AC plus BC minus AB plus BA minus B square minus A square plus AB. So now a lot of cancellations are there. So these two will cancel, and I think we are done. So minus 1 A plus B plus C minus A squared minus B squared minus C squared AB BC AC. So this is now I'll take the minus 1 over here and do the multiplication. This will be A plus B plus C whole multiplied by A squared plus B squared plus C squared minus AB minus BC minus AC. I'm going to open the brackets now. So you will have AQ plus AB square plus AC square minus A squared B minus ABC minus A square C BA square BQ plus BC square minus AB square minus B square C minus ABC plus A square C plus C plus plus C cube it was. Yeah. So this will be B square C minus ACB minus BC square minus AC square. So lots of cancellations are there now. So pay attention. AB square, AC square. Where is AC square? Over here. BC square, this will cancel. And A square B, A square C. So I think, B square C. This one will also cancel. So only you will be left with is A cube plus B cube plus C cube minus 3ABC, which is your RHS, right? So hence proved. Hope you understood that. Let's move to the B part of the question now. Okay. So now you have to find out the determinant of, not determinant, you're given that A is this matrix, then you show that A cube minus 4A square minus 3A plus 11I, that is the identity matrix, is equal to 0. And after that, you have to find out A inverse as well. So let's go with this question. Let's write, this is the B part. A matrix is 1, 3, 2, 2, 0, minus 1, and 1, 2, 3. Now you have to find out, first of all, I'll go with we have this A. Let's find out A square. A square will be equal to 1, 3, 2, 2, 0, minus 1, 1, 2, 3. Multiply 1, 3, 2, 2, 0, minus 1, 1, 2, and 3. So this will be equal to first row, first column, and all those multiplications, like when you will solve that, first row, first column, 1 plus 6 plus 2, 3 plus 0 plus 4, 2 minus 3 plus 6. Then you have 2 plus 0 minus 1, 6 plus 0 minus 2, 4 plus minus 0 minus 3, 1 plus 4 plus 3, 3 plus 0 plus 6, 2 minus 2 plus 9. So here you will have the matrix as 9, 7, 5. This will be 1, 4, 1, 8, 9, and 9. This is the A square matrix, right? And what about A cube? This is A into A square, which is 1, 3, 2, 2, 0, minus 1, 1, 2, 3, 9, 7, 5, 1, 4, 1, 8, 9, and 9, right? So let's find out the product again. This will be first of first column, 9 plus 3 plus 16, 7 plus 12 plus 18, 5 plus 3 plus 18, 18 plus 0 minus 8, 14 plus 0 minus 9, 10 plus 0 minus 9, 9 plus 2 plus 24, and 7 plus 8 plus 27, 5 plus 2 plus 27. This will be equal to, on solving, this will be equal to 28, 37, 26, 10, 5, 1, 35, 42, and 34. Fine. So we got all the items, right? We got A cube, we got A square, A already we have, and I we already know. Let's go to solve it. So to prove, I'm going to pick up the LHS. The LHS was A cube minus 4A square minus 3A plus 11I. So this is equal to 28, 37, 26, 10, 5, 1, 35, 42, and 34 minus 4 into A square. So 4 into 9, 7, 5, 1, 4, 1, 8, 9, 9 minus 3 into 1, 3, 2, 2, 0 minus 1, and 1, 2, 3 plus 11 into the identity matrix, which is 1, 0, 0, 0, 1, 0, and 0, 0, 1. Let's close that as well. Now, this is equal to, on solving, 28 minus 36 minus 3 plus 11, 10 minus 4 minus 6, 35 minus 32 minus 3. Here you have 37 minus 28 minus 9, 5 minus 16 plus 11, 42 minus 36 minus 6, 26 minus 20 minus 6, 1 minus 4 plus 3, 34 minus 36 minus 9 plus 11. So this will be equal to 0, 0, 0, 0, 0, 0, 0, 0, 0. And this is your RHS, right over here. So this is equal to 0. This was what you needed to prove, hence proved. Hope you understood that. So now using this same thing, you have to find out A inverse. Using this thing, you will have to find out the A inverse. I'm going to erase the screen because it is going to again take some time. Okay. So now we already had this equation as A cube minus 4A square minus 3A plus 11I is equal to 0. Now pre-multiplying both sides by A inverse. Pre-multiply. There's a difference, right? We'll just see. Pre-multiplying both sides by A inverse, you have A inverse into A. Okay. You can write A cube as A inverse into A square minus 4 into A inverse A minus 3 into A inverse A plus 11 into A inverse I is equal to A inverse into 0. This is equal to identity matrix into A square minus 4 into identity matrix into A minus 3 into identity matrix plus 11 into A inverse is equal to 0. which gives you A inverse is equal to 1 by 11 of 4A plus 3I minus A square. So that means A inverse will be equal to 1 upon 11, 4A. So A was 1, 3, 2, 2, 0, 1, 1, 2, 3 plus 3, I 0, 1, 0, 0, 0, 1, 0, 0, 0, 1 minus A square was 9, 7, 5, 1, 4, 1, 8, 9, and 9. Okay. Now let's solve that. This will be 1 by 11 brackets. You have a 4, not brackets, matrix. 4 plus 3 minus 9, 12 minus 7, 8 minus 5, 8 minus 1, 3 minus 4 minus 4 minus 1, 4 minus 8, 8 minus 9, 12 plus 3 minus 9. So here you have a, that was A inverse. A inverse is equal to 1 by 11 of 2 minus 2, 5 and 3, 7 minus 1 minus 5 minus 4 minus 1 and 6. This is the answer to the question, and this is the A inverse. Hope you understood that, right? Let's move to the next question, number 34 now. So again, you have a choice in this question. You have to find the intervals in which the function this is strictly increasing and strictly decreasing. We are given the function if x is equal to x minus 1 cube x minus 2 square. Let's find out the derivative because we have to talk about increasing or decreasing. So derivative isn't necessary. First function to derivative of second. So this will be first function into derivative of second, which is equal to 2 into x minus 2 into 1 plus second function into derivative of first 3 into x minus 1 square into 1. Correct. So this will be equal to x minus 1 square. I'm going to take it as common. And x minus 2 also I'll take common. So this inside will be 2 into x minus 1 plus 3 into x minus 2. So you have here x minus 1 square, x minus 2, and this will give you 5x minus 8. Right. For either strictly increasing or decreasing, you know this should be equal to 0, which means x minus 1 square into x minus 2 into 5x minus 8 should be equal to 0, which gives you x is equal to 1, 2, or 8 upon 5. These are three possible values, right? At which it may fluctuate. So let's talk about the intervals now. And sine of f dash x, which is equal to x minus 1 square, x minus 2 into 5x minus 8. And strictly, we'll discuss whether it is increasing or decreasing. So strictly increasing or strictly decreasing. So the first interval minus infinity to 1. From minus infinity to 1, this will be, see, from minus infinity to 1, this will be negative. Okay, fine, this will be positive. Okay, that means it is strictly increasing. Strictly increasing. And then from 1 to 8 by 5. See, from 1, if I'm taking it from 1 to 8 by 5, so this is again positive. So again, strictly increasing. From 8 by 5 to 2, it will be negative. So decreasing. And from 2 to infinity, positive. So strictly increasing. Right? So that means if I talk about when it is strictly increasing, A part, f is strictly increasing in minus infinity to 1 union 1 to 8 by 5 union 2 to infinity, and B part f is strictly decreasing in 8 by 5 comma 2. So these are the two answers to the question. Hope you understood that. Let's move to the second choice of the question. Find the dimensions of the rectangle of perimeter 36 centimeters, which will sweep out a volume as large as possible when revolved about one of its side. Also, you have to find out the maximum volume. Okay, so let's go with this one as well. I'll first of all say let length be x and breadth be or width y. So you know the perimeter is twice length plus breadth, right? We're given that this is equal to 36. So 36 is equal to this, which gives you x plus y is equal to 18, or x is equal to 18 minus y. This is number one. When the rectangle is revolved around its length and the dimensions of the cylinder are formed. So when rectangle is revolved about its length and then dimensions of cylinder are formed, then h is becomes equal to x and radius of the cylinder will become the width of the cylinder. In that case, what will be the volume of cylinder? You know, volume is equal to pi r square h. This is the formula. And what is the r? That was equal to y and h was equal to x. This is equal to volume. So v is equal to pi into y square. This is 18 minus y. I have used over here this equation from 1. Okay, let's write it from 1. So what you have to see in the question was, when it is revolved, we have to find out it will sweep out a volume as large as possible. So you have to find out the maximum volume. So for the maximum volume, of course, we have to go for the derivatives. So differentiating both sides with respect to y, this is equal to, this will be equal to 36. Wait, you have to find out of derivative of d by dy of pi 18 y square minus y cube. Okay, so this will be equal to pi into 36y pi into 36y minus 3y square. Correct? For the maximum volume, this should be equal to 0, which means pi into 36y minus y cube should be equal to 0, or 36y minus y cube, sorry, 3y square it was. This should be equal to 0. I'll take the 3y common from here. 12 minus y should be equal to 0. So either can be y equal to 12 or y is equal to 0. See, if y cannot be equal to 0, then it won't be a rectangle itself, right? That means I'll consider y is equal to 12. So let's find out the second derivative. D by dx squared, this will be dy by d of dx of this 36 pi into 36y minus 3y square. This will be equal to, pi will be taken outside, and this will be equal to 36 minus 6y. This is the second derivative. Sorry, d square v upon dy square. D square v upon dy square. Correct. Now, d square v upon dy square at y is equal to 12 is pi into 36 minus 6 into 12, which is equal to pi into 36 minus 72, which is minus 36 pi, right? That's, of course, negative number. Therefore, volume is maximum when y is equal to 12. volume. Hence, volume is maximum when y is equal to 12 centimeters. And when y is equal to 12 centimeters, what will be the value of x? It was equal to 18 minus y. So 18 minus 12, this is from 1, which is equal to 6 centimeters, right? So that means for the maximum values, what should be the sides of the rectangle? For maximum volume, x, that is equal to length, should be equal to 6, and y, which is your width or the breadth, should be equal to 12 centimeters. And what is the maximum volume? Maximum volume is given by v is equal to pi y square into x. So this is equal to pi y was 12 into 6, which gives you 144 into 6 into pi, that is equal to 864 pi centimeter cube. This is answer to the question. Right, so here we are, we had to find out the maximum volume, which comes out to be 864 pi centimeter cube. Hope you understood that. Let's move to the next question. Question number 35, you have to find the area of the region lying in the first quadrant enclosed by the x-axis and the line y is equal to x and the circle this. See, one such type of question will surely come in your examination. So be prepared. Like I have solved so many papers. One such question surely comes. The area bounded by the curve, the line, and all that. Okay. And one question from the linear programming problem. Surely these two topics are sure to have a question. Okay. Now, if I talk about this circle, x squared plus y squared is equal to 32. This can be written as x squared plus y squared is equal to root of 32 whole square, which is equal to 4 root 2 whole square. So this circle is having the center at origin because there is no x and y coefficients over here, terms over here. And the radius is, of course, 4 under root. And this is the radius and the center is at 0. The given line is equal to y is equal to x. So this is the line y is equal to x. And let's make the circle with the radius. Let's make this circle. This is not the perfect one. Wait. So this is the circle with the radius. This is the point 4 root 2 comma 0. Fine. Okay. Yeah. So you have to basically x-axis with this line, x-axis and this curve. So basically you have to find out this region, this area. So this area is made by this triangle plus this shaded part, right? So let's say this is equal to 1 and let's say this is equal to 2. Now I have to find out this point of intersection of them. So for that, I'll solve these two equations, 1 and 2 simultaneously. You will have x squared plus x squared because y is equal to x, so y squared is equal to x squared. This is equal to 32, or 2x squared is equal to 32, which gives you x squared is equal to 16, or x will be equal to plus minus 4. These are the two possible values of x. So if x is equal to 4, definitely the corresponding values of y will also be plus minus 4. So the point of intersection of these two lines and the circle is this. This point is 4, comma 4, and this point of intersection is minus 4, comma 4. Okay, but we are concerned only for the first quadrant, so we are not going to take this one. Now, the 2 points of intersection are 4, comma 4 and minus 4, minus 4. This point is lying in the third quadrant. So I'm going to ignore this and I'm going to take this because it is lying in the first quadrant as it is told in the question. So required area is equal to area of, let's name them first. So these ones, I'll say this is point A, this is point C, and this is O, and this is point B. Okay. So this will be given by area of AOC, AOC plus area of ABC, which is equal to integral of 0 to 4. See, this is the point 4. C is 4, comma 0. So 0 to 4 x dx plus 4 to 4 root 2 root of, because x square plus y square is equal to 4 root 2 square. So here you have a y as root of 4 root 2 square minus x square. So this will be equal to 4 root 2 square minus x square dx. This will be equal to x square upon 2 limits 0 to 4 plus x upon 2 root of 32 minus x square plus 32 upon 2 sine inverse x upon 4 root 2. The limits from 4 to 4 root 2. So this is gonna give me 16 upon 2 minus 0 plus 0 plus 16 sine inverse of 1, which will be equal to, okay, one more thing, minus, yes. So here will be minus 2 root 16 plus 16 sine inverse 1 upon root 2, which will be 8 plus 16 into pi by 2 minus 8 plus 16 into pi by 4, which will be 8 plus 8 pi minus 8 plus 4 pi, which will be equal to, here was minus. Okay, so this is equal to 4 pi square units. Right? So this is the answer to the question, 4 pi square units. This is the required area. 4 pi square units. Hope you have understood that. So let's move to the last question of this paper. This is question number 36. You have to show that the lines R is equal to A plus lambda B and R is equal to B plus mu A are coplanar, and the plane containing them is given by this. Okay. So you have the two lines as A1 plus, let's say this is A1. Wait. So generally, if I'm talking about the general one, if you are having the general A1 plus lambda B1 and R as A2 plus mu B2, they are coplanar if A2 minus A1 dot product with B1 cross B2 is equal to 0. Now, here A2 minus A1 dot product with B1 B2, this will be equal to B vector minus A vector, right? B minus A dot product with B2, which is equal to A, B1 into B2, which is equal to B into A, B cross A, right? So, see over here, let's write down this is A1, this is B1, and this is A2, and this is B2. Hope you're clear with this, like how I've substituted the values. So now this is equal to B vector dot with B cross A minus A vector B cross A. This is equal to B vector, A vector minus A, B, and A. This is equal to 0. Hence, the lines are coplanar. Right. And the equation of the plane containing them is given by equation of plane containing them is given by R minus A dot this is equal to 0, because R minus A dot with n vector is equal to 0. This makes R vector dot B cross A minus A B cross A is equal to 0, which gives you R B cross A is equal to 0, because A B A was already equal to 0 from here. Okay, so that's it. With this, all right, so this is equal to, that's it. This is what we needed to prove. Hence, proved. And students, with that, we have completed all the 36 questions of the set 1 paper. Hope you have understood them well. Yeah, these are 36 only. Hope you have understood them well, and don't forget to visit our website www.examsnet.com, where you will find a number of entrance exam question papers for your class 12 CBSE and entrance exam question papers as well for your practice. You must download our app for an easier access. The link is available in the description box. So very best of luck for this paper and your further papers. Keep shining, keep rising high. Bye. Hey, chunks of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your class 12 mathematics, physics, chemistry, and biology question papers. Also, you must download our app. The link is available in the description box for the better preparation. You must visit our website for the practice of the entrance exam question papers as well. So today we'll be solving in this video is CBSE class 12 2020 outside Delhi set 2 paper. This is in continuation with your set 1 paper. Do watch it up. Do watch our previous video for the set 1 paper. In this video, we will be solving only those questions which are not there in the set 1 paper. Okay. So very best of luck. Let's start with the question number 1 for this set. You are given that A matrix is equal to 200, 50, 10, and 2. B is equal to 50, 40, 2, and 3. Now you have to find out the determinant of the product of AB. Okay, you know this determinant of the product of two matrices is actually the product of the determinant of the two matrices separately. So for that, I need to find out the determinant of A. Determinant of A will be given by 200, 50, 10, and 2. Similarly, B determinant will be 50, 40, 2, and 3, which will be 400 minus 500. That is minus 100, and this will be 150 minus 80, which will be equal to 70. So the determinant of AB is equal to determinant of A multiplied by determinant of B, which is minus 100 into 70. So this gives the answer to be minus 7,000, and option D is your correct answer. Hope you got that. Next, question number 2, you are given that A vector is I minus 2j plus 3k, and B is a vector such that A dot, this is A dot B vector, is square of the magnitude of the B vector, and A minus B vector magnitude is equal to root of 7. Then you have to find out the magnitude of the B vector. All right, so this is the A vector. First of all, let's find out the magnitude of the A vector. This is given by 1 plus 1 square plus minus 2 square plus 3 square, which is equal to 1 plus 4 plus 9, that is equal to root of 14. Okay. Right. So what next? I'll start from here. You are given magnitude of this is equal to root of 7. Also know one thing that if I take the square of it, this is equal to the magnitude of A vector square multiplied by magnitude of B vector square minus 2A. Right? This is equal to root 7 square, and root A square, this is equal to 14. I don't know about B, and this is equal to 2 B vector, magnitude of B vector square, right? Okay. So this makes here was plus, sorry, here was plus in between. So this is equal to 7 minus 14, and this is B vector magnitude square minus 2B vector magnitude square, which is equal to minus 7 and minus B vector magnitude square. That gives you 7 is equal to B vector's magnitude square, or the magnitude of B vector is equal to root of 7. That makes option C to be the correct answer. Hope you got that. Let's move to the next question. Question number 3, 3 dice are thrown simultaneously. You have to find the probability of obtaining a total score of 5 in that. See, when the 3 dice are thrown, in this case, the total sample space, the number of the sample space will be 6 for the first dice, into 6 for the second dice, into 6 for the third dice. That's equal to 260. Now, let A be the event of getting a total of 5. Correct. So what are the possible outcomes that A can have? This will be 1, 1, 3, 1, 3, 1, 3, 1, 1, 2, 2, 1, 2, 1, 2, 1, 2, 2. So how many these possible outcomes are? There are 6. 1, 2, 3, 4, 5, 6. There are 6 possible outcomes. So you have to find the probability of getting the score of 5, total score of 5. This is equal to number of favorable outcomes divided by the number of total outcomes, which is equal to 6 upon 216. That is equal to 1 upon 36. So this makes option C to be the correct answer. Hope you understood that. Let's move to the next question number 4. So it says if fx is equal to 2 mod of x plus 3 mod of sine x plus 6, then the right hand derivative of fx at x is equal to 0 is. So you have to find out the right hand derivative of fx at x is equal to 0. So right hand derivative at x is equal to 0, this is what you need to find out. This is equal to limit h approaching 0, f of 0 plus h minus f of 0 whole divided by h, where h is very small, positive real number. Okay, so this is equal to limit h approaching 0 2 mod of h plus 3 mod of sine h plus 6 minus 2 into mod of 0, 3 sine mod of 0 plus 6. This will also be in the brackets. This whole thing is divided by h. So this makes it limit h approaching 0 to h plus 3 sine h plus 6 minus 0 minus 0 minus 6 whole divided by h. This 6 and 6 will also cancel out, and you'll be left with limit h approaching 0 to h plus 3 sine h upon h. This is equal to limit h approaching 0 to h upon h plus limit h approaching 0, 3 I'll write here sine h upon h. This is equal to h and h will cancel. So this will be equal to 2 plus 3 into, see, this thing is equal to 1. So the answer is equal to 5, right? That means you have not option actually. The answer 5 is the correct answer. Hope you understood that. Let's move to the next question. Question number 5, you have to find the integral of sine raised to power 5 x by 2 into cos x by 2 dx. Over here, I'll put sine x by 2 is equal to t. So this will make the derivative. Cos x by 2 into 1 by 2 dx is equal to dt. Or here you will have cos x by 2 dx is equal to 2 dt. So if I'll say this is equal to I, now the I becomes, now the I is equal to 2t raised to power 5 into dt. So its integral will be equal to 2 into t raised to power 6 upon 6, or this is equal to 2t raised to power 6 upon 3 plus c. Okay, what was t? T was equal to sine x by 2. So this is sine raised to power 6 x by 2 upon 3 plus c, right? This can be written as 1 by 3 into sine 6 x by 2 plus c. So this is the answer to the question, right? Hope you understood that. Let's move to the next question. Question number 6, if A is given by this matrix, then you have to find out A cube. Actually, this is really easy. It's a square matrix of 2 order. So A is equal to 1, 0, 1, 1. And you have to find out A cube. For that, let's first of all find out A squared, which will be given by 1, 0, 1, 1 multiplied by the same matrix. So, you know the rules, first row, first column. So it will be 1 plus 0, 0 plus 0, 1 plus 1 and 0 plus 1, which is equal to 1, 0, 2, 1. And you have to find out the A cube, which is equal to A into A square. A matrix was equal to 1, 0, 1, 1. And this is equal to 1, 0, 2, 1, which will be same rule, first row, first column. So 1 plus 0, 0 plus 0, 1 plus 2 and 0 plus 1. This is equal to 1, 0, 3 and 1. This is the answer to the question, right? So the answer to the question is 1, 0, 3, 1. Hope you got that. Next is question number 7. So here you have to find, we are starting with the section B, you have to find out the derivative of x raised to power log x with the respect. Okay, not this. So you have to find out the derivative of x raised to power log x with the respect to log x. See, in such type of questions, always what we will do, I will take these two functions separately and then find out their derivatives with respect to some common variable and then divide the two. Let's understand. Let's say this is equal to u and this is equal to v. So what will be du by dx? Du will, okay, before that, I'll say u is equal to x raised to power log of x. Now taking log on both the sides, you have log of u is equal to log of x raised to power log x. Correct? And now taking the derivative or differentiating both the sides with respect to x, you will have 1 by u log of u is equal to. Question number 7, you have to find out derivative of x raised to power log x with respect to log x. All right, so we have two functions over there. The first one is x raised to power log x, and we have to find out the derivative of this with respect to log x. In these type of questions, always we will assume them to be two different functions and then find out their derivative with respect to the common variable, which is x in this case, and then divide the two. Let's understand this. So here I'm assuming u is equal to x raised to power log x, and here I'm assuming v is equal to log of x, right? Taking log on both sides, you will have log of u is equal to log of x raised to power log of x. This will be equal to, this can be written as log of x into log of x, right? So this is your log. This is equal to your log of u. So log of u is equal to log of x whole square. Correct. Now differentiating both the sides with respect to x, you will have 1 upon u into du upon dx is equal to 2 of log x divided by x, or du upon dx will be equal to 2u log x upon x, or I'll put the value of u. So du upon dx, this can be written as 2 into x raised to power log of x into log of x whole divided by x. Now I'll get back to our v. We were sitting alone. Dv by dx, this is simply 1 by x, nothing else. That's it. So now you have to find out, actually what you need to find out was du upon dv. For that, you have to do du upon dx multiplied by dx upon du. So this is equal to 2 into x raised to power log of x into log of x whole divided by x multiplied by x upon 1. So these two will cancel and you will have 2 into x raised to power log x into log x as the answer to the question. Hope you understood that. Let's move to the next question. Question number 8, you have to find the distance between the parallel planes. This is the first and this is the second plane. You have to find out the distance between these two planes, right? So this is the first equation, 2x plus y plus 2z is equal to 8, and you have 4x plus 2y plus 4z plus 5 is equal to 0. If I divide both the sides by 2, here you will have 2x plus y plus 2z is equal to minus 5 by 2. Right. So this is the first one. See, this is the same. 2x plus y plus 2z is equal to 8. Or you can say minus 8 is equal to 0. And okay, fine. Wait. This is equal to 8. This can be written as 2x plus y plus 2z is equal, minus 8 is equal to 0. And the 2x plus y plus 2z plus 5 by 2 is equal to 0. Okay. So now the distance between the two, distance is given by the mod of minus 8 plus 5 by 2. Question number 8, you have to find the distance between the parallel planes, this and this. So these are the two parallel planes. Let's write them separately. You have 2x plus y plus 2z is equal to 8, and 4x plus 2y plus 4z plus 5 is equal to 0. If I divide both the sides by 2, you will have 2x plus y plus 2z is equal to minus 5 by 2. So see, these are the two same ones. 2x plus y plus 2z is equal to 8. That means definitely they are the parallel planes. Now you have to find out the distance between them. So distance between them will be given by 8 minus of minus 5 by 2 whole divided by root of 2 square plus 1 square plus 2 square, which is equal to 8 plus 5 by 2 divided by 4 plus 4 plus 1. This is equal to 21 upon 2 upon root of 9. This is equal to 3. And this and this will cancel. So you will have 7 upon 2 units. So distance between two parallel planes is equal to 7 by 2 units. Hope you understood that. Let's move to the next question, number 9. You have to show that the function f from real to real numbers defined by fx is equal to x upon x square plus 1 for all x belonging to the real numbers is neither 1 to 1 nor 1 to. Fine. Okay. See, if I'm taking this function for, let's say, 2 at x is equal to 2, this function f2 will be equal to 2 upon 2 square plus 1, which is equal to 2 upon 5. And for 1 by 2, this will be equal to 1 by 2 upon 1 by 2 square plus 1, which is equal to 1 by 2 upon 1 by 4 plus 1, 1 by 2 upon 5 by 4, which will be 1 by 2 into 4 upon 5, which is equal to 2 upon 5, right? So, see, they are the same ones. That means f of 2 is equal to f of 1 by 2, but 2 is not equal to 1 by 2, right? Therefore, f is not 1 to 1 function or a relation. Yeah, it's a function, okay? F is not a 1 to 1 function. Now, for, let's see for on 2. Let's say y belongs to this relation such that fx is equal to y. So this will be x upon x square plus 1 is equal to y, or x square y plus y is equal to x, or x square y minus x plus y is equal to 0. Here you will have x is equal to, so you have to find out the two roots right now. Yes. Okay. Let's find out the roots now. So the two roots will be given by x is equal to minus of minus 1 plus minus root of 1 minus 4y square whole divided by 2 into y is the first one, and the second one will be minus 1. No, sorry, this is plus minus. Okay. So this will be equal to 1 plus minus this upon 2y. right? So I hope you're clear this till here. See, over here, x is not real when x is not real when 1 minus 4y square is less than 0 or 1 is less than 4y square, which means y greater than half of square or y less than this and y greater than this. Therefore, for y belonging to minus infinity to minus 1 by 2 union 1 by 2 to infinity, there exists no x belonging to real numbers. There exists no x belonging to R such that fx is equal to y. Therefore, f is not an onto function as well. Right. That's it. This is what we needed to prove. It's neither one to one nor onto, and this is hence proved. Hope you got that. Next is question number 10. You have to evaluate the integral of minus 1 to 2 mod of x cube minus x dx. Okay. Fine. So let's put x cube minus x is equal to 0. You will take the x common. X square minus 1 is equal to 0. The two factors will be x plus 1, x minus 1, and rather three factors, x plus 1, x minus 1. So the three possible values for x are x can be 0, 1, and minus 1. So now why I have done all this, I want to break this interval now. So now this interval will become, like say that was equal to I. Let's say this is equal to I. So now this I will become, this is equal to minus 1 to 0, x cube minus x dx plus 0 to 1, x cube minus x dx plus 1 to 2, x cube minus x dx. So let's say this is equal to I1, this is say I2, and this is equal to I3. I'll solve all the three separately. Let's go for finding out the I, solving the I1 first. So I1 is limit minus 1 to 0, x cube minus x dx. This is equal to minus 1 to 0, x cube minus x dx. See, why I have removed the mod sign is because x cube minus x is greater than 0 for all x less than 0. Okay. So this will be equal to x raised to power 4 upon 4 x squared upon 2. Limits are minus 1 to 0. This will be equal to 0 minus of 1 by 4 minus 1 by 2, which will be equal to 1 by 4. Okay. Let's go for finding the I2 now. So this is equal to limit 0 to 1, same thing, x cube minus x dx. See, now it will be negative value, x cube minus x dx, right? Because this is going to be negative for all x lying greater than 0. This is when x is greater than 0, this is definitely going to be a negative. Okay. So, okay, that is it. So this is equal to minus x raised to power 4 upon 4 x squared upon 2, 0 to 1 minus of 1 by 4 minus 1 by 2 minus 0, which is equal to 1 by 4. Let's solve I3 now. This is equal to 1 to 2 x cube minus x dx. That's equal to integral 1 to 2 x cube minus x dx, which is equal to x raised to power 4 upon 4 x squared upon 2, limits 0 to 1 to 2. So this is equal to 4 minus 2 minus 1 by 4 minus 1 by 2. This is equal to 2 plus 1 by 4, that is equal to 9 by 4. Now, the I, it was equal to I1, I2, and I3 sum. So this is equal to 1 by 4, 1 by 4, 4, 9 by 4. That's 11 by 4. So this is the answer to the question. Hope you got that. Let's quickly go through some once again. So you have to evaluate -1 to 2 the limits were and the mod of x cube minus x. I have broken down this thing. See the three turning points are 0, 1 and -1. So I have broken this whole integral into three parts: I1, I2 and I3. From -1 to 0, see this will give me a positive value. For this will be always a positive value for all x less than is equal to 0. So I'm taking a positive over here. And this will be a negative value for all x lying between 0 and 1. Okay, that's going to be a negative value. Yeah, a negative value, because the more you are going to multiply the powers of x, the more powers of x you will be taking, the more smaller number this will become, and ultimately this will give you a negative term. Okay. And again, when x is lying between 1 and 2, this is definitely going to be a positive value. That's it. So using that, we solved the value for I1, I2, and I3, and then I added all of them to get my answer as 11/4. So this is the correct answer to the question. Hope you got that. Let's move to the next question now. Question number 11. Using integration, you have to find out the area of the region bounded by x, y, such that 0 is less than equal to y, less than equal to x square, and 0 less than equal to y, less than equal to x, 0 less than equal to x, less than equal to 2. So actually we have 5 inequalities over here. Let's see them. This is the given inequality set. So first one, you have y is less than equal to x square. Let's say this is number 1. And second is y is less than x. Let's say this is number 2. X is less than 2, and x is greater than 0. Y is greater than 0. So these are the 5 inequalities we have. Now considering inequalities as equations, considering inequalities as equations, you have y is equal to x square, y is equal to x, x is equal to 2, 0, and y is equal to 0. So if I solve y is equal to x square and y is equal to x, you have x square is equal to x, or x square minus x is equal to 0, x into x minus 1 is equal to 0. That means either x is equal to 0 or x is equal to 1. When x is equal to 0, y will also be equal to 0, and y x is equal to 1, y will also be equal to 1. So the point of intersection of the curve 1 and 2, these two curves, therefore points of intersection of curve 1 and 2 are 0, 0 and 1, 1, right? Let's plot them on the graph now to understand the problem better. So this is the point 0, 0, and this is the line y is equal to x. This is y is equal to x square. This is the line x is equal to 0. This is the line, okay, wait, now we had x is equal to 2. Fine. So let's say this is the line x is equal to 2. So this is the point O. This is the point, let's say over here, the point of intersection, this one. Let's say this is the point A, B, C, and D. Right? We already calculated the 2 point of intersection of this y is equal to x and y is equal to x squared. The 2 point of intersection are 0, 0 and 1, 1. Correct? Now what we else have? Okay, fine. Now what we need to find out is this region, this one, this shaded region. This one. We need to find out this particular region. Right? Let's write down required area is equal to integral 0 to 1 limits y of the parabola, y of the parabola dx plus 1 to 2. See from here, 0 to 1, this is 1 comma 0. So 0 to 1, y of the parabola plus 1 to 2, y of the line. Dx, right? So 1 to 2, I have to find out the area bounded by this line. Hope you understood till here. Now, very easy. We have done most difficult part of the question, or it's just an integral that we have to solve. So x square dx plus 1 to 2 x into dx. This is equal to x cube upon 3. The limits are 0 to 1, x square upon 2. Limits are 1 to 2. This is equal to 1 upon 3 minus 0. 4 upon 2 minus 1 upon 2, which is equal to 1 upon 3 plus 2 minus 1 upon 2. This is equal to 1 upon 3 plus 3 upon 2. This is 6 to 9. That is equal to 11 upon 6 square units. So this is the answer to the question, 11 upon 6 square units. So with that, we have completed the set 2 paper. Set 2 of this Delhi, outside Delhi 2020 CBSE class 12 paper. Hope you understood it well. Students, don't forget to visit our website www.examsnet.com to practice for your class 12, 20, mathematics, physics, chemistry question papers, as well as your entrance exam question papers. You must download our app. The link is available in the description box. A very best of luck for your exams. Keep shining, keep rising high. Bye. Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great tool for you for practicing your entrance exam question papers as well as your class 12 CBSE question papers. You must download our app. The link is available in the description box for a better performance in your exams. So students, in this video, we'll be discussing CBSE class 12 mathematics 2020 outside Delhi set 3 paper. We already have discussed set 1 and set 2 paper in the previous videos. So do check those videos for the set 1 and set 2. And in this video, we'll be solving only the questions which were not in the set 1 and set 2. Let's start with the very first question of this video. Here we go. Best of luck. The value of tan inverse, this is a correction in the question. This is tan. The value of tan of half of cos inverse root of 5 upon 3 is equal to. Let's say this is equal to y is equal to tan of half cos inverse root 5 upon 3. Let's say cos inverse root 5 upon 3 is equal to x. This makes cos x is equal to root 5 upon 3. And now getting back to this one, this will be y is equal to tangent of half of, this is equal to x, okay. So that makes y is equal to tangent x by 2. That makes y is equal to root of 1 minus cos x upon 1 plus cos x. And this is 1 minus root 5 upon 3 upon 1 plus root 5 upon 3, which is equal to 3 minus root 5 upon 3 plus root 5 whole under the root. Now rationalizing the denominator, you will have a root of 3 minus root 5, 3 plus root 5 multiply 3 minus root 5, 3 minus root 5 is equal to 3 minus root 5 square upon 9 minus 5. Because this is a square, a plus b into a minus b, that's a square minus b square formula I'm using over here. So that will be equal to 3 minus root 5 upon 2. This is the answer to the question, right? Let's check. You have option B as the correct answer. Hope you got that. Let's move to the next question number 2. So you are given a matrix. A is given by this matrix. You have to find out the determinant of adjoint of A. Okay. So this is a diagonal matrix, right? The A matrix is, let's write, this is equal to A 0 0 0 A 0 0 0 A. Therefore, what will be the determinant of it? This is equal to A cube only. This is not equal to 0. Thus, we have because this is a diagonal matrix, adjoint of A is equal to determinant of adjoint of A is equal to determinant of A raised to power n minus 1, which is equal to A raised to power 3 minus 1, that is equal to A raised to power 3 raised to power 2, which is equal to A raised to power 6. That makes option C to be the answer. Hope you got that. Let's move to the next question number 3. The line x minus 2 upon 3 is equal to y minus 3 upon 4, z minus 4 upon 5 is parallel to the plane. Which of these ones? Okay. See, the given line is, let's write down the line x minus 2 upon 3, y minus 3 upon 4, z minus 4 upon 5. Let's say this is equal to lambda. Now, any line which is perpendicular to the normal of this vector, see over here, 3i plus 4j 5k. Let's say this is equal to a vector. This will be perpendicular to normal vector of the plane. If I check with option D, checking option D, you have 3 into 2, 4 into 1, 5 into minus 2. This is equal to 6 plus 4 minus 10, which is equal to 0. Therefore, question number 3, the line x minus 2 upon 3 is equal to y minus 3 upon 4 is equal to z minus 4 upon 5 is parallel to which of these planes? Now, let's say this is equal to some lambda. From here, this vector 3i plus 4j plus 5k is equal to a. This will be parallel to the plane vector, right? So this vector will be the parallel to the, this will be actually a perpendicular to the normal vector to the plane. It will be very precise, right? In other words, it will be parallel to the plane itself. So if I go with this option C, over here, 3 into 2, 4 into 1, 5 into minus 2, this will be 6 plus 4 minus 10, which is equal to 0. Therefore, 2x plus y minus 2z is equal to 0 is parallel. This plane is parallel to the given line, which makes option C to be the correct answer. Hope you understood that. So now let's move to the next question, number 4. You are given that f of x is equal to, there's a misprint over here. This is x into this. This is mod of x. So the given function fx is equal to x into mod of x. You have to find out f dash x. See, this is pretty easy, right? Now, this can have two values. This will be equal to positive x squared if x is greater than equal to 0. And this will be negative x squared if x is less than 0. So the derivative of it, this will be positive 2x if x is greater than equal to 0. And this will be negative 2x if x is less than 0. That's it. This is the answer to the question. Next is question number 5. You have to find the integral of 1 upon x into 1 plus x square. Let's say this is equal to 1 upon x into 1 plus x square dx. So I'll multiply the numerator and denominator by x. This will be x squared into x squared plus 1. Let's put x squared is equal to t. Then you will have 2x dx is equal to dt. That makes your I is equal to 1 by 2 dt upon t into t plus 1. This is equal to 1 by 2 integral of t plus 1 minus t upon t into t plus 1 into dt, right? So this is 1 by 2, 1 by t minus 1 upon t plus 1 whole dt. So now it's easy to find out the integral of the two. This will be half of log of t minus log of t plus 1 plus c. Now let's get back and fill in the value of the t. This will be half log of, you can write it better as like t upon t plus 1 plus c. Or what was t? This is x squared upon x squared plus 1 upon plus c. Okay, so this is the answer to the question, right? We don't have any options, but it's the answer to the question. Hope you got that. Next is question number 6. If this denotes the greatest integer function, then you have to find out the value of this integral. Let's say that's equal to I again, 0 to 3 by 2 greatest integer function of x squared dx. See now, this will be, I'll break it up to like 0 to 1 x squared dx plus 1 to root 2 x squared dx plus root 2 to 3 by 2 x square dx. Right. See, from 1 to 0 to 1, what is the greatest integer function? This is 0. In this interval, greatest integer function, because you have to take the lowest value. So this is equal to 0. And for 1 to root 2, see, this value is root under root 2 is equal to 1.432. So between 1 to 1.432, this is going to take definitely the value of 1. So 1 into dx, limits 1 to root 2. Now you're left with the last one, limit root 2 to 3 by 2. So this is equal to, see, this is 1.432 to 1.5, right? This will give you 2 into dx. Okay, greatest integer function. So I'll be taking over here 2. That's it. This is 0. X limit 1 to root 2. And this will be 2x limit root 2 to 3 by 2. This will be equal to root 2 minus 1 plus 2 into 3 by 2 minus root 2. So this is root 2 minus 1 plus 3 minus 2 root 2, which is 2 minus root 2. This is the answer to the question. Hope you understood that. Next is question number 7. So you have to show that the function fx is equal to x upon 3 plus 3 upon x decreases in this particular interval. Okay, since we are talking about the increasing or decreasing of the function, I have to go with the derivative of the function. This is equal to 1 by 3 minus 3 upon x squared. So this can be written as, I'll take the LCM, 3x squared, x squared minus 9. Now, f is decreasing when this is less than 0, which means x squared upon x squared minus 9 upon 3x squared is less than 0, or x squared is less than 9. You know, x is not equal to 0, definitely. So x squared is less than 3 square, which makes x is equal to, see, there will be the limits, right? So x will lie between minus 3 to 3, right? Therefore, fx decreases in -3 to 0 union 0 to 3, right? That's it. So this is hence proved. Hence proved. Hope you got that. Let's move to the next question now. Question number 8. It says three distinct numbers are chosen randomly from first 50 natural numbers. You have to find the probability that all the three numbers are divisible by both 2 and 3. So here, three distinct numbers are chosen from the first 50 natural numbers. So number of, like how many numbers you have to choose, you can say sample space, it will be given by 50 C3. This is the number of elements or number of pairs in the order in the sample space. So in this one, numbers divisible by both 2 and 3 from first 50 natural numbers are 6, 12, 18, 24, 30, 36, 42, and 48. Simply you have to move with the table of 6. Okay. So what is this? Here the number, let's say this is equal to A. So here the number of A is equal to 6. Right? Now, not sorry, 6, 1, 2, 3, 4. This is 8. Okay. Now the required probability. You have to choose 3 from this 8 divided by, you have to choose from 50. So this is equal to 8 factorial upon 3 factorial into 5 factorial multiply. This is equal to 50 factorial upon 3 factorial into 47 factorial, which is equal to 8 into 7 into 6 upon 3 into 2 multiply 3 into 2 divided by 50 into 49 into 48. So these two will cancel out and this and this will also cancel out. This will cancel at 7. So this is equal to 1 upon 350. This is the answer to the question. Hope you understood this. So 1 upon 350. Let's move to the next question, number 9. You have to evaluate 0 to 1 root of 3 minus 2x minus x squared dx. Okay. Now this can be written as 0 to 1 limit. I'll take the minus common inside the root. This will be minus x squared plus 2x minus 3 dx. So this can be 0 to 1 root of x plus 1 square minus 2 square, right? Dx, this is equal to 0 to 1. Then now this was for whole. Now this can be written as root of 2 square minus x plus 1 square dx. Now this is the formula for the integral for this will stand with x plus 1 upon 2 root of 3 minus 2x minus x square plus 2 squared upon 2 sine inverse x plus 1 upon 2. Limits are 0 to 1. So now I'm going to put in the limits. This will be 2 upon 2 root of 0 2 sine inverse 1 minus 1 by 2 root of 3 plus 2 sine inverse 1 by 2. So this is equal to, this will be 0, 2 into pi by 2 minus root 3 by 2 minus 2 into pi by 6. This is equal to pi minus root 3 by 2 minus pi by 3. This is equal to 2 pi by 3 minus root 3 by 2. So this is the answer to the question. Hope you understood that. Let's move to the next question now. Question number 10, find the general solution of the differential equation dy by dx plus 1 upon x is equal to e raised to power y upon x. Here you can write down dy by dx is equal to e raised to power y upon x minus this. This is equal to e raised to power y minus 1 upon x. That's equal to dy by dx. Or you can say um, this will be dy upon e raised to power y minus 1 is equal to 1 by x into dx, right? Now I've put the integral on both sides because I'll be integrating both the sides. Now this is equal to, I'll multiply the numerator and the denominator with e raised to power y. So this is it. E raised to power y minus 1 into dy is equal to integral of dx upon x. Let's put this e raised to power y is equal to t, or you have e raised to power y into dy is equal to dt. This will be dt upon t into t minus 1 is equal to dx upon x. So this is equal to, this further can be written as t minus 1 into t minus 1 dt is equal to integral of dx upon x. This is equal to 1 upon t minus 1 dt minus 1 upon t into dt. This is equal to integral of dx upon x. So this is log of t minus 1 minus log of t is equal to log of this, log of x plus say log of c, the constant. This is log of t minus 1 upon t is equal to log of c into x. Now removing log on both the sides, t minus 1 upon t is equal to c upon x. T was e raised to power y minus 1 upon e raised to power y is equal to cx, or e raised to power y minus 1 is equal to cx into e raised to power y, or 1 minus e raised to power y is equal, no, this can't be. You will write it as 1 minus e raised to power minus y, because I'm dividing both the sides by e raised to power y. So this will be 1 minus e raised to power minus y is equal to cx. That's it. Here I have divided both sides by e raised to power. Okay, so this is the answer to the question. Hope you have understood that. Let's move to the next question now. The last question for this set, question number 11. So you have to find the image of the point this on this given plane. Fine. Let's talk about general formula. We know that image of x, y, z of point x1, y1 and z1 in a plane ax, by, cz plus t is equal to 0 is given by x minus x1 upon a, y is equal to y minus y1 upon b is equal to z minus z1 upon c is equal to minus 2 ax1 by1 c z1 plus t whole divided by a square plus b square plus c square. Thus the image of the image of point minus 1, 3, 4 in plane x minus 2y is equal to 0 is equal to x plus 1 upon 1, y minus 3 upon minus 2, z minus 4 upon 0. This is equal to minus 2 into 1 into minus 1, minus 2 into 3 0 into 4. Whole divided by, this is 1 square, that's 1, plus minus 2 square, which is 4 plus 0. Okay. So this is it. This is x plus 1 upon 1 is equal to y minus 3 upon minus 2, z minus 4 upon 0. This is equal to minus 2 into minus 7 upon 5. That makes x is equal to 14 by 5 minus 1, which gives you the value of 9 by 5. Y is equal to minus 28 upon 5 plus 3. That's equal to 15 minus 13 upon 5, and z is equal to 4. Okay. So that's it. We got the point. The image of minus 1, 3, 4 is 9 by 5, 13 by 5, and 4. This is the answer to the question. So students, with that, we have completed all the 11 questions of your set 3. And this completes your CBSE class 12 2020 outside Delhi, all the sets. Hope you understood that well, and don't forget to visit our website www.examsnet.com for a better preparation of your class 12 examination as well as your entrance exam question papers. You must download our app for a convenient preparation for your examinations. So students, that's all for this paper. Hope you enjoyed. Keep shining, keep rising high. A very best of luck. Bye.